Composability. This week, Vincent is joining us to tell us about why we should put TensorDict in PyTorch core. So, Vincent, do you want to take it away?
Sure. Yeah. Thanks, Edward, for the presentation. So, I work for TorchRL mainly. So, I'm basically like the POC for reinforcement learning at PyTorch. TensorDict is basically the main primitive we came up with in TorchRL, which is solving. It used to solve a very specific problem in reinforcement learning, which is that you have very heterogeneous classes which have signatures that can be quite different, but the logic of the script is usually the same. Like, you have a policy that interacts with an environment and things like that. And what we wanted to do is to basically abstract away the signature of the various methods that we have and just have something like a dictionary that we can pass from one class to another, regardless of what it contains, really. Um, and we came up with the idea of TensorDict because we wanted to do things like stacking those dictionaries together, sending those dictionaries from one device to the other, or synchronizing those dictionaries across nodes or similar things. And so basically, it kind of made sense to augment this dictionary, augmented dictionary class, with tensor operations. So that's the first thing we came up with. We put at the beginning, we put that in Travel. And early users from the library and people at Meta that were doing RL slash other things said, well, this is awesome. We should use that independently of reinforcement learning. And so that's when we basically talked with various people in the org, and we decided to make a standalone library called TensorDict, which used to live in PyTorch Labs and now PyTorch, and that contains this basic primitive. Then we added loads of stuff in the library, but the more we're thinking about it, at least from our side, the more we think that it would make sense to have that in PyTorch core. And the first thing that made me think that is basically input from users. So basically, people telling me that would make so much more sense for us to import that directly from PyTorch. It's really a missing feature from PyTorch from their point of view. Um, no, I understand that it's a pretty big PR already, and so that there will be obviously discussions, and there are lots of features inside it, and lots of obviously things we need to talk about. But that's kind of like the history and what brought me here. So more in detail, I think that TensorDict can help people across various problems and various open issues that we have in PyTorch. So I already created a PR that I use as an RFC. And I can share my screen to show a little bit about that. Right. So, so what I did here is first, like I wrote a little bit about the purpose of the class itself, and then I delved into basic usage and concepts. So there's a lot to read here. I'm not gonna go through everything. I thought that maybe right now a good thing would be to go first through the basic things that it can do, and then elaborate a little bit more on what are the problems I think we can solve with that. And there is a second part of that description, which is here, which is probably a bit more to the point, divided in 3 points. So first, why should it be in core? And I will come to that later. Uh, why should we not worry about backward compatibility if we integrate TensorDict into core? And why should we not fear maintenance? So the first thing I'm going to say is, what should we not fear maintenance? I feel that for my job in reinforcement learning, TensorDict has a much higher priority than TorchML. And the reason for that is that there are very big reinforcement learning libraries out there, and that use PyTorch. And what those guys have told me is that, yeah, maybe in a very distant future, we will adopt TorchML as the backend, to do some of the stuff we do. But the first thing we're going to do is certainly adopt TensorDict because we have similar abstractions and they're hard to maintain. And we think that TensorDict could be the right solution for us. And I got that input from various people that are quite influential. And so that basically tells me, okay, that seems to be the one thing that is really filling the gap in reinforcement learning. So I'm not saying I want to merge that for reinforcement learning. That's absolutely not what I'm saying. What I'm saying is that regarding maintenance, I would be very happy to take that on me and make that my top priority, to maintain TensorLink on the long term. Okay, that's one thing. I think that code speaks better than words, and so I'm going to show you a couple of things that TensorLink can do. I think it's probably more didactical for you to see that. So the basic thing of TensorLink is that it's a structure, a dictionary that can store tensors. It does the casting from like NumPy arrays or integers or whatever to tensor if you need to. A bit like when you call torch.tensor and you put an integer in it, right? So here I'm creating a TensorDict. I just say the key 1 has value 1. The key 2 is itself a dictionary that has a key 3, and the key 3 has a value 3. And when I create that, here I have an element that that will explain after, which is the batch size. And I say that it has an empty batch size, which is basically the shape of my TensorDict. So now I've created that TensorDict. My key 1 is now a tensor. You don't see it here, but it has the value 1, obviously. And the value 2, 3 has a value 3. And as you can see, it has a batch size that is empty. So what is this batch size? The batch size is basically the leading dimensions of all the tensors that we have in the TensorDict, and it's completely arbitrary. So you can select an empty batch size, and then you cannot benefit from any of the shape features of TensorDict, because you cannot do like split or chunk or whatever on your TensorDict, but you can still do many things like .CUDA or do things like distributed operations and this kind of thing. Right, so if I want to manipulate the batch size, what I do here is that I create a fourth key, so I assign it using this, and I say it's a random number, two random numbers, and then I expand my TensorDict exactly like you would expand a tensor, and I obtain a TensorDict now that has a batch size of 3. Right, so what that means is that I can now index along the shape dimension of the TensorDict. So it has basically a shape, and you can index it like you index a tensor. And so you have two kinds of indexing. You have the key indexing, so I can index the various keys that I have. And under the hood, I'm going to read that and interpret that. Okay, this is a string, so it must be a key. And if it's not a string, then by default, a string or a tuple of strings. If it's not that, then by default, it must be an indexing over the shape. So these are the various kinds of indexing that you can do. I'm not going to talk too much about that. You can index with none to do unsqueezing, all the kind of things that you can do with a tensor. And one of the things that I want to expand a little bit more on is serialization. So basically, in TensorDict, what we needed in reinforcement learning is to have what we call replay buffers. So it's basically dynamic data set that you dynamically fill and empty during training. And so we created that using memory mapped arrays or in this case, memory mapped tensors. And what we want is to have a fast indexing of that thing in order to do fast sampling of the replay buffer. And so we came up with this thing of calling TensorDict.memMap, and you can put a directory if you want. And if you put a directory in that function call, then it's going to write the structure of the TensorDict, every single tensor as a separate memory map tensor on disk, along with a JSON file for each and every level that carries the metadata of that TensorDict. So you see that here we have two TensorDict, the root and the TensorDict number 2, and we have two metadata.json that lives there along with the various tensors that we have in the TensorDict. Another thing that we use in RL is functional calls. We use PyTorch quite a lot, and TensorDict has a slightly different API in terms of functional calls. So what you do here is that I create a transformer, I create some input data, and then I call TensorDict from module. I give my nm.module, and it's going to write this nested TensorDict that looks exactly like my transformer, in the sense that it's every level of the transformer is now a level of the TensorDict. And I can take that TensorDict to the parameters and call toModule.net, use that as the context manager, and I can call my network, and now I obtain, what I've done here is that I have called 0 on my TensorDict, so I've zeroed all the value in it, all the values in it, and what you see is that when I do that, and I call using functional calls my network, I get an output that is 0, And if I call back my network, the parameters have been reinstantiated, exactly like with torch.func.functional call. So this is basically an alternative to torch.func.functional call. By the way, in the PR, I also overload functional call to work with TensorDict such that both options can be used. But yeah, so that's one thing that you can do. You can also vmap over TensorDict. That's when the shape of the TensorDict comes in very handy. For instance, if you're doing ensemble learning or this kind of thing, so you can basically vmap. You can stack all the parameters together contiguously and then call vmap over that. And TensorDict works perfectly with that using its batch size. So the batch size is now something that is really key into making vmap possible. If we had not the batch size, we could not really say, okay, this is the dimension 0, because it's because the TensorDict has the dimension 0 that vmap can work. We have some distributed features. You can send, receive, call, reduce. Like we have various things for um, distributed training, and those functions all have the same signature as the distributed function they relate to. One thing that we want is also for Tensor. So basically, TensorDict, you already see that we have two kinds of usages. One is more related to data, and the other one is more related to parameters. And so when you're using data, and if you look at Hugging Face data sets, for instance, they have this thing called map, in which you iterate over your data set and you apply some transformation over the whole data set. We have the same thing in TensorDict. So if you have this huge TensorDict that is stored on disk using memory mapped arrays, and you can index that thing quite easily, we have a TensorDict.map, and you can have a map function that you call on that. And you're going to split your TensorDict in various chunks, so to say, access each of these chunks on disk, provided obviously that you're storing that on disk. And it's going to be like quite fast, to do those operations, because you can dispatch that using multiprocessing, etc. So that can come in quite handy when you're doing preprocessing. And we also have TensorDict.apply. And in this case, what you're going to do is that you're going to go through each of the leaves of your TensorDict and apply a certain operation. That can be an algebraic operation, for instance, in this case. And you can also apply between two TensorDicts and these kind of things. Like it comes in with various features. Yeah, the kind of thing I wanted to show in that demo is that we also have the option of locking a TensorDict. It can come in quite handy if you have a TensorDict and you don't want people to mess with it, and add new keys, etc., and predict very precisely what is going to happen. So you can lock it, and again, you can use that as a context manager. So here, the TensorDict will be locked only within that context manager and unlocked after that. And obviously, when you lock a TensorDict, you also lock all the sub-TensorDicts in the structure. Right, so those are the features. Now, I don't know if there are already questions, but maybe I can jump on what are the problems that we're trying to do, that I think we could solve by putting TensorDict into core. So there is an idea, first idea of parameter serialization and state-dict. So from my point of view, one of the very nice features of TensorDict is that it's very structured. So if you take this TensorDict from a module, as I've said, the TensorDict has a structure that mimics the structure of the module itself. So you have like nested dictionaries. That means that when you're doing things like either functional calls, but also if you want to do something like load state dict, sorry, and or the TensorDict version of that, you could split that operation over the various modules very easily, because it's very easy. You just take one module and you say, okay, let's load the corresponding level of TensorDict onto that. And you don't have this big data file saved on disk with torch.state that is humongous and very hard, to load, because all the tensors, all the parameters of your model and all the buffers are saved independently on disk using this file.memmap with an adjacent JSON file that represents the metadata, as we showed before. So basically, that solves the problem that I think that now that we're getting models that are increasingly big, it can come in quite handy to do these kind of things. One question that was raised regarding that is, how do you do parameter tying? It's still an open question. I don't have a precise answer to that. I'm not sure it's the one thing that is going to block the feature. I'm sure there is a solution. It's just that it's not a problem I've had in the past to deal with. And so I always let that on the side, thinking, well, will come a day when I will try to solve that thing. That thing, sorry. Sorry. What else? So uh, I say that you can load partial models. So if you just want, to dump a part of the model and then load that part of the model, it's very easy. Or if you have saved just one part of the model, you have saved the whole model, but you just want to load one part of the model to do a partial checkpointing, also it's very easy. Yes, Horace?
Um, I guess I'm kind of still trying to understand like how I should think of TensorDict. Is the main like difference between just a TensorDict and like I suppose a PyTree in general, and like tree mapping over the PyTree that like operations on it are transparent? Because like I guess from my understanding is you can take a TensorDict and you can do like times two, which then
Yeah.
applies times two to all the tensors within the TensorDict. But for example, you could also do this by maybe just like having a PyTree and doing tree map on top of it. Um,
Yeah, so it's a people that know PyTree, it's the first thing that they tell me, like, oh well, you could just get away with PyTree. For many operations, it's true. For algebraic operations, it's true, but that's also why we don't implement any algebraic operation in TensorDict. We consider that this is not TensorDict's business, and plus, it can store anything like even Boolean values for which algebraic operations do not really make sense. Okay, right. So what are the differences with PyTree? First thing, TensorDict is compatible with PyTree. So we register it within PyTree and you can call PyTree. Second thing is VMAP. So yes, you can VMAP over PyTrees, that's the whole point. But here there's a slight difference. So imagine that I have batches of, let's say, parameters or data that is multidimensional. And I would like to do a VMAP over the last dimension that I consider to be the batch dimension, right? And I don't know that in advance. So what I would like to do is to do VMAP minus one, the input dimension minus one. Basically saying, this minus one dimension is the time dimension. I would like to VMAP over that. You can do that with TensorDict because you have the batch size, and this batch size is telling you, okay, the first dimension, for instance, is the batch, the second dimension is the time, and so if you do minus one, you're going to do the VMAP over the time. You cannot do that very easily with a minimap. With a PyTree, you will need to know in advance what your dimension is. That's a very slight advantage. Probably not worth coding a whole new class with that, but that's already something. The other thing is, I think that compared to PyTree, the big thing is I think the metadata that you can carry. So you can say things like, this TensorDict is locked and I cannot modify it. This TensorDict is on CUDA because it has a device. Some TensorDict can have a device, and so you can basically say, well, let me check where that TensorDict is. It does not necessarily have a device because you can store tensors that are on different devices. But if you put a device, everything will be on the same device, and so you can check that. It's a metadata. You have other metadata like the batch size. You can check what is the common size of all the tensors that you're having on TensorDict. So there are various things, that like all those metadata that I think are pretty useful. And the fact that you have those operations that are already coded facilitate a lot to what you're doing. For instance, the fact that you have this way of saving the entire TensorDict on disk using memory map and then loading it, those are very handy features. And I think that having the same data format to solve many problems, together with something like, hey, we think that this is the proper way to batch to do bags of tensors, at scale. I think it can come in quite handy because when people ask, oh, how can I do that operation? You don't need to tell them to, oh, well, you need to call PyTree the tree map over this and that, and then solve this and write 5 lines of code when actually we just have one line of code that does something like tensordig.cuda or these kind of things. I don't know if that answers the question.
uh, I guess maybe it kind of also depends on like how I haven't looked at the code yet, but like how much code is like TensorDict? Is it like a relatively thin wrapper over like an underlying container of some kind with utilities defined on it?
Yeah, so Many many operations are coded using apply. So I've shown that we have an apply. And when you do, like, for instance, tensor_dig.cuda, it's gonna do tensor_dig.apply tensor.cuda, and so it's gonna dispatch all the tensors on CUDA, and then finally it's gonna update your metadata. So many operations are just coded like that. Same thing with permute, same thing with transpose, same thing with unsqueeze or squeeze. It just updates the metadata of your tensor_dig along with a call to apply. For some of the things, it's a little bit more convoluted. For instance, indexing has a lot more logic behind it because we need to check, oh, well, what are you giving to me? It's a tuple of strings. Okay, if it's a tuple of strings, then I know that I need to index along the string dimension or the key dimension. If you give me something else, I need to do the indexing along the chain dimension. So those kind of things are a bit less easy to code. But yeah, that's basically the way I would put it.
All right, and is apply basically just tree map?
No, it's not. It's not because of this metadata thing. So imagine that you have a tensor_dig that has an empty shape, and it contains a tensor_dig that has a shape. Okay, and then I do something like tensor_dig.unsqueeze 0. So I add, a first dimension with shape 1. I'm gonna need to do that on the nested tensor_dig 2. And that's why I need to call apply, because if I just call PyTree over all the leaves, I'm not changing the metadata of my nested tensor_dig. And that's why I need to do that. But like the overhead is very, very tiny right now, and we're working on making it even smaller. Usually for most operations, the overhead compared with PyTree is about 5 to 10%, and we can reduce that, I think, quite easily to 5%.
Basil?
All right, yeah.
Hey, so I think this actually follows the line of Horace's question, but at least as a thought experiment, does it make sense to imagine a version of TensorDict that is these services implemented against an internal PyTree?
Yeah, so this is something I thought about. One of the features, it's arguable, but one of the features I like about TensorDict is that you can subclass it and implement your own TensorDict. So for instance, in the TensorDict library, we have a TensorDict that represents H5DB data classes. So you have an H5DB data class, which sort of looks like a TensorDict already, because you have those nested keys and things like that. And so it's very easy to map that onto a TensorDict. So we thought, oh, well, that's the ideal use case. We could write a subclass of TensorDict that just reads that thing. And when you access the TensorDict inside, you're reading the H5DB. I guess we could do something similar with Arrow. But once you're starting to do that, if you implement the entire TensorDict with PyTree, then you're going to bump into some problems because, like, it's much easier to do the recursivity within TensorDict, because then we know that when we're doing these H5DB TensorDict, we can just recycle the same tree operations, if you see what I mean. Whereas it wouldn't be the case with PyTree.
Okay. So in addition to the extra services, you're actually using sort of an internal store that's optimized for the operations that Tensor.
Yeah.
Okay. Cool.
Any other questions? Horace, did you have another one?
I think maybe I need to read the issue deeper, or read the issue closer. I think for me, I guess about my opinion of whether, I think I would need to understand like it seems like one of the main differences here is like the TensorDict has like an additional metadata on top of it.
Yeah, I think there's a metadata, but there's also like all the extra utility that goes with it that I think is really what this PR is about. If you look at the kind of problems we're trying to solve, if you look at things like state dict and load state dict, yeah, sure, you could do the same with PyTree. I'm not saying the opposite, and probably you could build something on top of PyTree that does the exact same thing. Again, not saying the opposite. Uh, Regardless of that, I think that having one class where you can do, this sort of partial loading and all the partial saving and saving, with a data structure that looks like the data structure of your model, those kind of things are very, very handy. And we can't just tell people, oh, use PyTree and deal with it. I think if we can come up with something on our own, that solves that problem, that's amazing. No,
Or so
whether it should be coded using PyTree or not, I don't know. But I think that having one class that does that is useful. And the other thing is, in the case here, for instance, of PyTorch, like for instance, the PyTorch API I showed. Um, from my point of view, with the usage I have from functional calls, one of the things I do all the time is doing functional calls on methods that are not forward. As of now, it's not something that is coded within PyTorch. Probably there's a way around that wouldn't be too difficult, but currently it's not something that is implemented. And with TensorDict, it's very easy because you have this TensorDict context manager that can do that for you. So again, for PyTorch, when you need to dump your parameter into a model and take them back, again, it's quite easy. Yes, we could do the same with PyTree. Yes, we could do the same with a class that is built on top of PyTree. But I think the second option of having a class that is built on top of PyTree is better than just saying we have PyTree and it could do that, but we don't provide the tool. Yeah.
Yeah. So I guess one last question. Do you view like conceptually, do you view a TensorDict as closer to a tensor or closer to like a PyTree, I suppose?
We have this thing that when we say a nested tensor, we call the nested tensor something that is a tensor, but it's actually nested. And we have this thing that when we say tensor something, it's more a something than a tensor. And that's why we called it TensorDict and not dict tensor. It's because it's definitely not a tensor. It's definitely more a PyTree.
I see.
If I had to define it, it's more about the data structure itself plus extra features from tensors than being a tensor itself. And personally, I really don't want that to be a tensor plus, or a tensor like.
I see. Yeah, makes sense.
NYC.
And also for algebraic operations, well, that's one of the big things. It can carry, as I've said, data that has very different D types, and that's important. Like for instance, you can have the labels and the images, from a data set together in the same TensorDict. To me, that doesn't really look like a tensor. It looks like a data structure that contains tensors.
NYC?
Yeah, I definitely agree with the thing that intrigues me about this proposal is definitely more of the data type or like the state-dictness of it. And I guess I have two questions. I think you did write about aspiring for this to kind of be a state-dict representation, and there are a few restrictions. One of the things that, one of them is the fact that you're assuming things are tensor only. We talked about some of this offline, and maybe the metadata will help. But I think the second part that I'm curious about is, have you talked with distributed people yet? Do you have their thoughts on whether this could help with sharding or checkpointing? Because if there's no additional features for TensorDict beyond what a PyTree would offer, it would be hard to be like, oh yeah, we should add this complex thing into our system. But if it could offer certain things that would solve checkpointing issues with DCP and FSDP or whatever other functional PyTorch stuff, that would be quite interesting.
Yeah, so I have not had the chance yet to talk with these guys. It's on my to-do list, and I think in my opinion, again, there's a clear use case for that, in terms of all these kind of operations like flattening parameters and then sharding the parameters and then doing an all gather, all these kind of things. I think would be very handy with TensorDict because you could just have the data structure and call that and say, hey, go over those nodes and collect all the tensors, maybe just for that sub module and not for the rest. So that would be, in my opinion, very handy, and also for serialization, etc. Everything would be built in. but yeah, I still need to talk with those people and see if they see any value with that. I wanted like to um I guess I wanted to have the PR already quite ready, in a sense that I have like a better understanding of how that would fit in within PyTorch. And I think that I'm the stage right now where I personally can see that. And so that's probably the right time to have that discussion. I think that earlier I had a little bit more doubts about how things would fit together. I think my story is better now.
Yeah, for sure. I think it'd be valuable to like make sure that TensorDict could actually be, I guess, a standard in a sense for representing things with tensors in it. So I'd be curious what they say. I would also push for more consideration, and we can talk offline about supporting optimizer state dict, which is a little different, like quite different from the parameters in the modules, just because it has other non-tensor things and has like a differing structure that I think might be interesting. But yeah, thanks.
Has TensorDict been used with optimizers at all, or not really? Mostly mono?
No. Oh, I guess I wouldn't know.
Albin, what are you thinking right now? I'm calling on you.
What am I thinking? I don't think I have much more to add from what I've said before. I've discussed with Vincent, and I've
Can you
quickly
restate
chatted with
what you've discussed with Vincent for the benefit of the
Sure. I think at the high level, I think I see this discussion going forward in two different possible ways. One is we have a concrete use case in core for this. I know that being distributed checkpointing, that being any other feature in core that would actually be significantly simpler to implement and have a path to implement it using this. Or the other way is we want to say that generally we say that we need a way to hold a bunch of tensors, and that TensorDict is kind of a nice middle ground between nested tensor on one end and an actual list of tensors, or whatever you can PyTorch over on the other hand. And we say that we need something in the middle that has a bit more structure, but not so much structure as nested tensor. And we say that TensorDict is the right way to go with that, and we want to kind of bless it. And so we would need to move it in core to say, yes, that's the right abstraction. People like it. Let's just say we have to use it now. I think for either of these, we need someone to be able to, that is familiar with core, to sit down with Vincent to figure out what's the best way to add this to core, to, use it the right way, to popularize it, to make the PR go forward. So we need some kind of sponsor on our end to help Vincent move this forward, whatever is the reason to move it to core.
Okay, so let me just do a straw proposal. So Vincent spent a lot of time talking about the serialization aspects of TensorDict, and like that's something that we are currently in discussions about. Actually, I wanted Nikita to come to the meeting today, but I don't think he can make it. So let me just be super concrete. What if we do a TensorDict based serialization as the new safe by default serialization in PyTorch?
Why would it be safe?
Well, I mean, the basic concept here is like if you're going to change the format. Well, let me see. So, okay, so it's safe because there's no pickle involved.
Yeah, that's the one-liner.
No, but that is not a real thing. Like if you want to, we have a weights-only version already in core that is using pickle and that is safe. So pickle is not a problem here. Pickle opening arbitrary objects is a problem, and we can already solve that with the weights-only flag we already have in core. And I'm confident Pickle has been scrutinized enough that there is no security issues with its implementation.
Isn't there like a giant warning on the pickle page saying it's insecure?
Yes, if you use it with the default mode, that can load arbitrary objects, because you can create such an object that will execute arbitrary code when it's being loaded.
So Alvin, I don't understand what you're saying, because like right now that we're in negotiations with Hugging Face about safe tensors in PyTorch. Vincent, I don't know if you know about safe tensors or not.
Yeah, I do actually. So we have this comment here about safe tensors from IBM, and they basically saying they would rather use TensorD than safe tensors. So good for me. But yeah.
So like Alvin, just saying like, oh, Pickle is great. I mean, we have had some of these discussions, but like empirically, if I just think about like what conversations are in flight right now, no, the story is not, yeah, just use weights only pickling. It's safe. Like this is definitely not like what the actual state of the world is. Like maybe you're right on a technical perspective, but like socially that's not the situation.
Right. But the thing is, that's why the only discussion, well, there is two discussions in flight, and the way I look at them are, weights only is the right solution for us if we want to easily improve the default behavior in PyTorch to make it more safe, enable safe weights only, and that's it. Integrating safe tensor is going to be a whole bunch of work. Why we would want to do that is because of two reasons. One is there are many users of safe tensor out there, and so for the people that want to use that, we should be able to load them. And that one I agree with you. Introducing a new format is not going to help with that. If we have to pick one, it has to be safe tensor, nothing else. And two, there are, I think, other considerations where in some more constrained setting, Pickle cannot be used at all. Irrelevant on how you use it, it cannot really be imported. And for these users, I would agree that safe tensor is the right alternative because that's already there and working.
Alvin, my interpretation of what Ed was saying is more along the lines of like, we don't actually know if weights only like will work in real use cases. Like we haven't actually tried it. It just like literally plugs the whole of I don't know this type, I'm not going to let you serialize it. But like if people actually try to serialize and deserialize reasonable PyTorch programs, we don't know if that will work. Now that's like independent of the storage format, but like weights only, I wouldn't really consider a real thing at this point.
Horace?
I guess back to the like TensorDict discussion. I think from my perspective, it seems like there's two main functionalities here, and I guess maybe correct me if I'm wrong, but it seems like one of the functionalities here is around like representing the parameters of a module and kind of calling it in a more functional way. Is that correct? Like, and then the second functionality is like representing data sets, and here the details about things like memmap and stuff like that are more important. Is it correct?
Well, for parameters, you also have the serialization aspect, which is just in the two things you just said. You know, like if I want to save the parameters of my model on this, and just load part of that model because like I'm doing some fine tuning of whatever, you know, I can easily do that. So there is a little bit like there is a continuum between the two. That's what I mean.
But I guess I'm mainly thinking here about like kind of the delta between like just passing PyTorch in and like TensorDict, and it seems to me like the two main areas where there's like significant value add of TensorDict is one when like working with modules and parameters, and the second one is like when working with like large data sets or
yeah, that's usually the way I say it. The way I say it is usually to say it's useful to represent data sets, and it's useful to play with parameters.
Yeah. I guess maybe my overall feeling is I feel like or at least maybe from a PyTorch perspective, one thing we've kind of like talked about for a long time / played with is kind of the idea of like making modules into PyTrees, or basically kind of having like a more of a first class ability to support like transforming over like modules in kind of a more functional manner. And like today's approach with like functional call and whatever kind of works, but I think we've kind of wanted for a while a bit more of like a first class support.
Yeah. So
module.
my take on that is, and what I like about Jax-like coding is that you're basically not saying parameters is a different thing than data, because at the end it's just numbers, so to say. And so in TensorDict, you still have the distinction in the sense that it's two different objects, your data and your and your parameters. But the way they interact with the module is a little bit more similar than it used to be in PyTorch. And so like functional calls, like you basically bring those things together in a nice way. For instance, the way that you call VMAP, you could have a data with several batches, a batch of data and a batch of parameters, and you want to call VMAP over the two, one parameter per one data. And you could do that, with VMAP and just say, well, VMAP 0, 0, and it's going to call, that over the two. So my point here is I think it's nice to have the data and the parameters that are, personally, I think it's nice to have them represented with the same data structure, especially for functional calls. Yeah.
Okay.
New York?
Yeah. I wanted to, from the checkpointing perspective, I wanted to just like, think about Ed's proposal, like, hey, can we even use TensorDict as state just by default? And I guess there are two parts. One, it's going back to before, like, I feel like there are different, like, I think it would be important to make sure that this is actually a standard that is useful for most of our things. So like optimizer state would also have to be supported, which today I don't think TensorDict can do. And the other thing I think I appreciate about TensorDict over PyTrees today, right now, is like you guys have the substring prefix handling that I don't think it exists in PyTree today. So like that's already something that would make serialization better for checkpointing. And I'm just curious. Yeah, I feel like I would basically want to get the opinions of other distributed people about whether it's possible TensorDict can be standardized across everything. For now, it seems like it can with the whole flattened, unflattened stuff.
Actually, let me just put something out there, right? Like a TensorDict can always represent anything that was just a dict of tensors. Vincent, do you agree with me?
Yeah.
So if you're able to like express the checkpoint state as a dict of tensors, then TensorDict will work.
Right, but optimizers have things that are like intentionally scalars or like a bool or something, or strings, and also like lists, which I'm not sure if would be supported. And I don't know if that would kind of break the invariant of like, oh, this is always Py-treeable. I could just be wrong.
Well,
like
if it's something like AMS grad equals true, well, that's something we can put in the metadata, or / use tensor class for that. Have like something like, oh well, for ADAM. So tensor class did not talk about that, not to overload, but tensor class is the data class version of TensorDict, and it's just like a basic data class format that all the operations fall back on TensorDict. And so you can build your data class with dedicated methods and like non-tensor data. And yeah, so you could put all of these things in the metadata, save them in the JSON file, and load them. Now, if your metadata is super big and you have like a list of things, well, I guess that in this case, it's probably something that you could represent as a tensor and you should represent as a tensor. So unless it's like a very, very long text, I think the metadata could solve that problem.
Yeah, I'd agree with the metadata solving the problem. I think it would work. It's just like a list of configurations, so it's not a huge deal.
Yeah.
But yeah, I just wanted to. I think my point is just that I would want TensorDict to be applicable to all our use cases, distributed optimizer modules, and I feel like the proposal currently talks mainly about like module parameters. So
Well, if that's the case, I'm very happy to sketch something for checkpointing optimizer.
Just to check something real quick. So when I subclass TensorDict, what happens to the serialization format?
Yeah, good point. So the serialization is implemented in the TensorDict base class. Do you know the memory map thing? And the only thing it's doing is that it's recursively going through all the keys. And if it's a tensor, it saves that on disk. And if it's not a tensor and / if it is a TensorDict, then it applies the same method recursively. And so if you do a TensorDict subclass, this method, unless you write it, is going to do the same, going through each of the lists and dump them on disk with a data structure that mimics.
So just to understand correctly, although you said you could just stash things in metadata.json, that's not like, I don't think that doesn't sound like the default mode of use for.
So imagine, let's take the following use case. I have a TensorDict. I have a tensor class within my TensorDict. It's entirely possible. Okay, you can store your tensor class inside the TensorDict. Now, my TensorDict, when I call memmap, what it's going to do is that it's going to save the data of the TensorDict in the first folder, and then in the nested folder, it's going to put my tensor class. And when doing the loading, it's going to look at the metadata and like try to load things where they should. And if it cannot load things where they should, it's going to fall back on basic TensorDict class. So basically, you can have those complex nested structures with subclasses of TensorDict and load them and save them. And by playing with metadata, you could find your way around that.
Albin, on the safe tensor question, it kind of feels like, well, I don't know how widely used TensorDict's serialization format is, but it seems like safe tensors is very similar to TensorDict's format, except that safe tensor cats them all into one file, whereas TensorDict keeps them expanded in a directory structure.
Yeah, I think TensorDict is also more nested. Like any folder within there is a valid nested TensorDict, while safe tensor would just be the top one is valid.
Yeah, it's on one level. Yeah, that matches my understanding of safe tensor. Okay, so I don't know, Horace, if you still want to like do 5 minutes on your topic.
Maybe I can try.
Okay.
So this is in the context of distributed, or sorry, quantization, and basically the use case essentially is they want to do like a graph transformation, but they wanted to work in a partial graph world, like on top of Torch compile, and so we don't really have a good way of doing this today for a couple different reasons, and the most fundamental one is basically just that like our like Torch compile stack is meant as like a single monolithic stack in some sense. You cannot apply a dynamo transformation. Like you cannot apply a transformation based off of dynamo and then compile that again. So in particular, the thing that I would want to do here with quantization is I would want to modify the state dict as part of the graph transformation, then load my state dict from memory, or save my state dict, or load my state dict from disk, or save my state dict to disk, and then I want to compile it on top. Does this make sense? In some sense, perhaps you can imagine what I want is I want like Torch compile with a custom backend to give me back, a real module, and then I want to be able to Torch compile on top of that again. Yeah, Alvin?
Just what you're describing, would having hooks on saving a state dict and loading a state dict be what you want to do these transformations?
No, or like I mean like I also need to do things like transform the actual operations that are being executed. But you're asking like, can I just replace the torch compile based transformations entirely with state dict hooks?
I meant combine your torch compile transformation with a state dict hook so that you can make them behave the way you want.
I mean, maybe, but this doesn't solve the problem that you can't like torch compile, modify the graph, and then reapply torch compile on top of that.
Okay. Yeah, no, that is no.
I
Okay.
mean, like I guess maybe the fundamental thing that like issue here is that like if you imagine something like fx.symbolic trace, right? Like a core design principle of fx.symbolic trace is that the graph module you get out can be treated just like a normal n.dot module. Like you can load the state dict, you can save the state dict, you can fx.symbolic trace again, you can do whatever. And so this is what allows for composability between one fx transform and another fx transform, or another thing afterwards. But we don't have that property today with Torch Compile. And in some sense, like I think we definitely would need to add additional restrictions here if we wanted to provide such an API. For example, it would probably need to be based around like a module, as opposed to being able to wrap like an arbitrary function. Greg?
Do you need a whole graph within the section that you're looking at?
Sorry, say that again.
Within the section that you're concerned about, do you need a whole graph?
Well, no, like in this case, you actually only need like pretty local information, relatively speaking.
So graph breaks are okay.
Graph breaks are okay, yeah.
Okay.
But like you can imagine that even if graph breaks were not okay, or sorry, I guess maybe let me give like another perhaps like use case that I've kind of thought about for something like this. Let's say I wanted to implement a custom activation checkpointing strategy based off of a graph. How would I do that today? Or like I wanted to like get the AOT autograph graph and then implement a custom activation checkpointing strategy there. It's not. If I wanted to do this today, the best thing to do would probably be to use AOT autograph directly. Implement like a custom partitioner and then return that function. But ideally, I would like to be able to just implement it on top of Torch compile, or perhaps shouldn't be called Torch compile. Perhaps it should be called like Torch. I don't know, like Torch transformer or something. And then I can compile that afterwards. Brian.
What was I thinking? I get like so I feel like the way you're describing it is there's like a series of transforms and the user explicitly like runs compile to get a graph at like some level of some transforms that's run and then like explicitly call another transform. And I guess I could imagine another version of that where the exact same set of things happen, but the user like calls torch.compile once and then like it all happens. And like the way I'd imagine happening is like we have the right hooks in our compile stack to let you like override at the right behaviors.
Yeah. So, I think the main motivating example for why this is not sufficient is that like in this case, after I do the transformation, the like my state dict should change. Like I want additional fields in my state dict, and so I want to be able to do my transformation and then save the state dict. I want to be able to do my transformation and then like load load a state dict, and that's not possible if it's done all in one shot as like hooks into Torch compile.
All right, Horace, I'm gonna make it easy for you. Sure. So specifically, concretely, what you need is you need a way to not disable Dynamo recursively on the compiled code product, which we do by default to like make sure we don't keep dynamoing the same thing. And obviously you need to generate a product that can actually be dynamoed through. So it's easiest if it's actually an FX graph that you call the compiled code on. But it's short.
Yeah, I would also like a second requirement. I would like it. I also want some way of linking up the parameters in my torch compiled graph back to the module, or back to the state dict of the module I'm transforming.
Okay.
If that makes
Sure.
Okay.
Well, Dynamo knows this information. We just don't expose it in a.
Wait, do you know this information?
Yeah, we do. Because how did you had to access the parameters, so the parameter we had to have gotten it from a module, so we know this information.
Or I mean, so concurrently, basically, what I would be proposing here would probably basically be another front end API, like analogous like Torch compile or Torch export. You could call it Torch transform or whatever. That would have these kind of slightly separate properties that make it amenable for transformation.
Don't we have too many frontends already?
Well, depends on what you mean by that.
Multiple export and multiple entries to Dynamo.
That's like a separate issue. I think. Voss?
Yeah. So if you just want an FX graph that you can run, and then some remapping, probably in residuals, why not do this as a backend? Like, why do you need another front end for this?
Or like I need to be able to then reapply Torch compile on top of it.
I mean, your backend can be anything. You could probably do that in the FX graph that's lower to your backend, right?
Or basically I want to take my module, like run my module transform with some stuff, and then save my static, load my static, and then I want to be able to reapply Torch compile on top of that. So it's not just a matter of like calling actually, is it? Well, it's possible you could implement this entirely as a backend within a backend, but I think in this case the semantics are different enough that it warrants like another front end.
I'm not sure it does. I think we can talk about this after, but it seems like all you're getting in the code gen that you really care about is going to be like a function pointer to your compiled thing. And since you're doing eager, like all you care about is the FX graph. So maybe you just need more information past your backend or like a context object you can read stuff off of. But you should be able to implement this entirely in a backend, I think.
Oh no, like when I say like another front end here, I don't mean like a significantly different like.
Yeah, you mean like an entry point, but I don't think we need another entry point either. I think you should be able to pass in just like a custom little lambda that does everything you need.
I guess I'm a little bit more skeptical about that.
Okay. Well, if you write like a function that is just operating on FX graph, we can talk about like
sure. Okay, but it seems like people seem to generally understand what the problem is and like seem to agree that we can solve it. Such, I guess it's worth solving, or maybe people are unconvinced about it's worth solving, but people do seem to think that we can solve it.
Okay. It's in line with the idea that PT2 is a replacement for symbolic trace, which is better. It's also in line with the stuff going on where you want to be able to make effects through a torch compiled region. So yeah, I think it's consistent with where we're headed. It is a little recursive, so that's kind of wild, but okay, thanks everyone. Yeah. See you all next week.